Assalamualaikum guys, my name is Ehsan. Today I'd like to talk about loop engineering. The concept sounds a little bit scary, sounds too techy, too AI, but it's definitely a great need of our times. We need it. We will simply learn it today. That why do we need it? Whether it's helpful for us or what's going on with it. Now, to understand loop engineering, we also should understand the initial concepts before loop engineering. um, so the most of us probably know AI as simply a chatbot. Like we ask chatbot a question or we give it a prompt and it simply replies. That's most of us probably would know chatbot or AI as we have now today. But the problem is that those replies do not actually solve the problems that we have. I mean, it gives you the response, it gives you the reply, it tells you what to do, but then it does not solve the problems because the real life, the real work has steps. The real work has, we have errors, we have bugs. The real work also needs like, checking, constant checking, and also that real work needs corrections. And unfortunately, the simple replies do none of those. So we needed the loop engineering. Loop engineering, what it does, it takes an action for our initial command. Then it checks what happened after that initial process is completed. Afterward, after the check, it decides what to do, what should be the next step, and then it repeats the whole process until the whole process runs smoothly and there are no errors. So this is what loop engineering is. To understand it better, we should go back to the initial stages, the initial concepts of this engineering. The first one, as I have on the example on the screen here, is prompt engineering. Prompt engineering is something telling a model to do a task, telling a model to do something or asking a question in simple words. For example, here, um, I have an example of cooking a dal chawal. Now, when we do a prompt engineering, we will simply ask the agent to cook a dal chawal. That's all we're going to do under prompt engineering. Or probably maybe give it some sort of, an idea like you are a cook, cook a dal chawal, like a basic quick command. But the problem with this is that this information is not enough. What happens is that the agent is now is going to start guessing, like how to cook the dal chawal, how much salt you need, how much oil you need, do you want any sort of high spices or strong spices in it, or you don't want strong spices, things like those. So that lack of information making agent guesswork is absolutely not needed and absolutely considered as dangerous in our real life. So, to avoid this guesswork, to avoid this danger, we needed to give some sort of information, like an external information or knowledge to agent to do the command much better than what we originally had. And that is when the context engineering came in to avoid the guesswork. What is context engineering? Context engineering is simply giving agent some external knowledge, some additional instructions, and asking it to perform the task based on these external tools or extra knowledge that we have provided. For example, in our example here, when we say in our prompt engineering just cook dal chawal, we did not have any specific instructions with it. With the context engineering, we have added the instructions with it, we have added the recipe with it, and we have also asked specifically like how to cook it. So in this recipe, in this example here, or in this recipe, We are asking agent to cook the dal chawal, of course, and also providing information like we have the ingredients of the dal chawal, like we have the rice, the dal, the tomato, onions, garlic, all that, the spices, and we're also asking it to cook like in a medium spices and the time giving it like this is the time that you must cook it in. So you are giving a lot more details, a lot more ingredients, and a specific time, the taste. So now the agent will perform better because it has a lot more knowledge. It can make a better decision now based on those external knowledge that we have provided. But again, uh, is it enough? Is it all that we could do? You know, probably not. So far until now, we have learned the prompt engineering and the context engineering. So just to quickly revise before we jump on to the next concept, is that the prompt engineering simply controls the instructions, and the context engineering controls the information. So with the prompt engineering, we only had the instruction in our prompt, nothing else. But with the context engineering, we had the instruction plus we gave some information. So prompt is just the instruction, context, instruction plus information. But there is still a problem that some tasks are not just single replies or not just a quick reply, but almost a complete project. So, what if we need to inspect the files? I'm talking about the tech issue now. What if we need to inspect the files? We need to understand like the whole structure of that file. Sometimes when we make a project, we make a plan. We also need to edit the code sometimes. Uh, and we also this is very important that we also should run the project as well in order to test it. So we need to run the test. We also should be able to read the errors, fix the bugs. Then again, of course, we need to run the test again, and we should keep going until the whole project starts working, the system starts working. But the problem is, like, if you give the whole task as one prompt, it will forget some details. And it will also repeat the old mistakes. So that is why we needed the next concept, the next engineering, which is called the harness engineering. Now, to avoid the harness engineering, I'm sorry, to avoid those issues, like the agent was forgetting details, the agent was making, mistakes, to avoid all that, what we do, like with the harness engineering, we make it manage the work, even outside the model. It stores the task list, it tracks progress, it gives agent tools, run commands and save results and all that sort of stuff. Now, with our example here, we are actually giving it a little bit of more organization in order to complete the task. For example, here, we are giving it a complete plan, like, it should wash the rice, wash the dal first, then cook the rice, cook the dal, give it a tarka, prepare the tarka, mix and simmer. So, I mean, it's like we are giving it a lot more instructions, detailed instructions, and kind of bounding it to that specific instructions so that it does not deviate from that direction. It does not deviate from those instructions and it stay within the limits of those instructions. So it does not make mistake. And this is how we can achieve a better result. So now AI is breaking the whole work into simple steps, like small steps. So it's going to perform one step, complete that step, and then move on to the next step. Like here, it's going to wash the rice and dal first, and then it's going to start cooking. But with the context engineering and prompt engineering, it would do whatever it feels like doing because we did not have the specific instructions and detailed instructions in there. So this is what the harness engineering is, to control the instructions and have it executed. So far, our stacks look like the prompt engineering is something that controls the instruction, The context engineering controls the information because we have added the information now with the prompt. With the harness engineering, we are now controlling the execution. So we had the prompt, instruction, we have the context, information. Now we have the harness, which is the execution, practical steps. Okay. So now we have all that. But uh, so why do we need loop then? In the loop, what happens is like the whole process needs to be repeated in such a way that it keeps on checking if there is any new issue comes up, if there is any new information comes in. For example, uh, we are cooking dal now under harness engineering. All of a sudden, we are out of gas. The gas stops. So with harness engineering, it wouldn't know what to do. But with loop engineering, is going to, since it's keep on checking, is going to keep on checking whether the we still have the warm flame coming up from the gas stove, or has it stopped. Is going to keep on checking whether the rice are properly boiled, the dal is properly boiled, not overcooked, not undercooked. So it's going to keep on checking. Sometimes you have a low flame, so rice and dal is probably going to take a longer time. Sometimes we have a high flame, so it's going to cook quickly, quicker, much quicker than probably we had on in our recipe. So so which might call it so loop engineering is something is going to keep on checking for for the errors and bugs during the whole process, and it's going to keep on checking for any new information that comes in. For example, in our process here, if we say, well, we needed to adjust the flame is too high, we have to lower the flame. Loop engineering will do that. Harness will not do it. Loop engineering will also check if we needed more water in rice or more water in dal to make it properly boiled. So so loop engineering is something that's going to keep on checking and make the decision and make the additions or take away any process or any step if it's needed. And to make it understand better, it is not simply that is we can call it like it's trying again. It's not just a simple try again. No, not at all. It is more than that. It's like it's evaluating any triggers about the next step. It's also verifying the whole process if it's running according to the process, according to the recipe, when it should it stop sooner than what the recipe had said earlier? Because harness is not going to stop. Harness is just going to follow the recipe, whatever we had given it. But loop engineering probably is going to stop even sooner than the recipe, or maybe take longer than the recipe if it is needed. So is what the loop engineering is. So in other words, we can also call it like a loop engineering simply converts an AI chatbot to a fully automated system. Well, the recording is still going on. Yes, good. It's going on. Okay. All right. So I have a couple of other examples. Quickly, we're going to do the other examples and then we're going to end the video. Let me see how to do that. Okay, good. Now, we have two more examples here. I just want to quickly go through it. Like here under prompt engineering, we are asking it to make a quick AI app that helps the students in studying. So you're giving like a simple instructions AI to build a basic idea, a basic app. With the context engineering, we're giving it a lot more information. So we are asking it to build an app. An app should have, and it should be for the middle school students. It should have, these are the subjects it should have. It should explain in simple words, give examples, and include practical questions. We are giving it like a lot more instructions than what we had in the prompt engineering. Whereas in harness engineering, we are actually giving it some sort of tools and the data storage and also the rules so that it gives us a better answer. So it is now like it is now following the specific instructions, following using the specific tools and doing the specific process according to the strict rules that we have given it. So it's not going to deviate from the rules that we have given it. Now, under the loop engineering, what it's going to do is going to keep on working on it. It's going to keep on checking if there is any sort of improvement is needed, if there is any sort of additional information that needs to be added, or anything needs to be updated or changed or deleted. So this is what loop engineering is going to do in it. And I think I should end it here, but there's another example here. You can pause the video and go through with the fourth example here. Thank you so very much, guys, for listening to my very first video, and I hope I did it good. I hope. Do send me your comments. Do let me know how you feel it, how you like it. If I need to improve anything, need to change anything. This is my very first try. And thank you so very much again for listening and watching. All right. Bye bye.